Hi everyone. In this video, we are going to be looking at how to represent an equation in a straight line graph. This video has a preceding video where I talked about the description, how to describe a straight line graph. Okay, I'll be posting a link to that video in the comment section. Okay, but here we are going to see how to represent a given equation as a straight line graph. Now, but before we do that, we need to have a basic understanding. Like we have here, y equal to mx plus c. You can see that y and x are variables here. They are both variables. That means their value changes. In the previous video, I mentioned that y is a dependent variable and x is an independent variable. But I'd like you to notice also that m and c are constants, okay? So the slope is a constant, the intercept, the y-intercept on the y-axis is also a constant, giving us y equals mx plus c. So I say it this way, you must arrange your equation such that it should look like variable equal to constant variable plus constant, a variable equal to constant variable plus constant. So your y is a variable which stands on its own. Mx is constant variable. That means when you have a situation where there is a constant and variable, that is your mx, then c is just constant. Now you may not understand this now, but as we look at certain questions, our understanding would be better. Okay, so let's see some questions here. Now the first one says, okay, it says, the question here says, use the equation to state how you would find the unknown constants graphically. Sketch the nature of the graph in each case, okay? Now let's start with the first one. Now the first one is P over R equal to LR plus L small r. Now, if you notice by the right of that equation, we are given that R and L are variables. So in questions like this, you're going to be given the variables and others becomes a constant. Like we have here, P and R are constants. Now, this is very um, important. So we are going to, let's copy that. Let's try this. And P over R equal to LR plus LR. Okay. So here we have P over R equal to LR plus LR. I need to be sure. Let me check that quickly. Yes, that's correct. So R and L, the capital R and the capital letter R, then L are the variables. So now, if you look at the arrangement of this, you will notice first off that P here is a constant, R is a variable, so here we have constant variable, okay? Then L is, for here is a constant variable. L here is a variable, R is a variable, so that's variable, together they are a variable. Then while L here is a variable, while small r here is a constant, okay? So if I am to write this as an equation, we are going to say this is mx. Let me use this. Okay, I'm going to say this is mx, that's for p over r because it's a variable constant. Then here I'm going to say this is y, lr is a variable. So then I'm going to say here is also mx, so it does not look like a straight line graph. And that's because we have constant variable equal to variable plus constant variable, and that is not what we want. So we must find a way to transform this equation to look like a straight line graph. And not only that, to draw a graph that represents this. Okay, so we are going to do this quickly. Let's rub this off. Okay, fine. So now the first thing I can choose to do here, anything, you can do anything as long as what you're doing is correct, okay? The first thing that comes to my mind here, I can choose to multiply through by r. If I do that, it means that this becomes p equal to this becomes LR squared now plus this becomes LR then small r. Well, I may not need to continue here. That is because P is a constant. That can be our C. That's P here. Now LR squared here, they are all variables, so that can be our Y. P is C. LR squared can be our Y. Then LRR can be our MX, where small r is your M, okay? Then capital LR is our X, okay? So this is already looking like a straight line because I'm having constants, I have variable, then I have variable constants. So the only thing is that I must make Y the subject of formula, meaning that I can transform, I can rewrite this as, let me rub here off. Okay, so I can rewrite this as LR squared, okay, equal to LRR minus P. Okay, no, I think that's a mistake. LR squared will be equal to negative LRR then plus B. This is what it should be, plus B. Let me, plus P, okay? So this is looking exactly like what we have. And if I'm to represent this, this is Y, okay, which is a variable, just variable. Then here we can call this mx, which is constant variable. Then your p here is c. But in this case, the equation is y equal to minus mx plus c. Okay, I want you to take note of this equation. So let's draw a graph representing this equation quickly. Okay, so in this case, it means we're going to have a graph. So we are plotting a graph. Our graph is going to look this way. We're plotting a graph of LR squared here as y, our y-axis. Then we have LR here as our x-axis. Okay. Now notice that the graph has a negative slope and a positive intercept, meaning that my line is going to touch the positive y-axis, which is positive intercept, and it's going to be a negative slope. That means it's going to steep down from left to right. So it's going to steep down this way from left to right. So this is exactly the graph. And so I can come now and say that my slope, the slope of this graph here is equal to a constant, which is small r, a constant here, which is small r. Let me highlight that for us to see. This is it, that's a constant here. Okay, then y, my intercept, the intercept to this graph is going to be your p, which is the constant that is standing on its own, this one here. That represents our C. Okay, so this is the answer to the first question. This is very important. But as we continue now, I know some questions will be coming to your mind. How about if I transform my equation to look differently from this? Yes, that is also correct. Okay, as long as you can represent the equation as y equal to mx plus c, no matter how you transform it, it is also correct as long as you do your algebra correctly. So let's quickly see another question here. The next question here says n, that's number 2 question, n equal to b over lambda squared, where n and lambda are variables, a and b are constants. Okay, so let's write that. So I think we have n equal to, sorry, to n equals to a plus b over lambda squared. Okay, now let's see again which are the variables. N and lambda squared are variables, a and b are constants. Okay, based on what I see there, I don't think we have so much to transform here. The reason because here is a variable, n is a variable, so I can call that my y. A is a constant, so I can call that my C. B over lambda squared is a constant variable, so I can call that my mx. So there's nothing really here to transform. So the question is, what graph are we plotting here? So this is what my graph will look like. We are going to be plotting a graph of n against 1 over lambda squared. Okay, so we are plotting a graph of n against 1 over lambda squared. That means your graph must be a graph of y against x. So my y is, which is a variable, is n. Our x, which is also a variable, is 1 over lambda squared. And if you notice, the slope is positive, okay, plus b, and the intercept is also positive. So that means it's going to it's going to go upwards from left to right, having a positive intercept. So I'm going to have something like this. This is exactly what my graph is going to look like. So I can say here that my slope, the slope of my graph will be equal to b, and y, the intercept of my graph, is equal to a. And that is the answer to the question. This one is quite straightforward. We don't need any transformation here because it is written in as y equal to mx plus c. Okay, so let's see another question. This says f squared equal to ab, and we are given that a and b are variables, so f is a constant. Let's write that. So we have f squared equal to ab are variable. So the way it is here, this guy here is a constant, which we can call c. Ab here is a variable, which is y. So in this case, it means we are going to have a graph of y equal to c. But this is not the intention, of the question. So we must find a way to transform this to look like y equal to mx plus c. Okay, so let me rub this off. So how do we transform this quickly? I can choose to divide both sides by a or divide both sides by b. They are both variables. If we do that, we're going to have f squared over a equal to b. So here now we can say that f squared over a is already a constant variable, which is mx. Constant variable is mx, where the m is f squared, the x is 1 over a. Then your b here, we can say it is y. So you see, this equation is y equal to mx. Now, our graph now is going to look like this. We are plotting a graph of y against x. So my y here is b, and my x here is 1 over a. Okay, 1 over a this way. Sorry, 1 over a. Okay, and if you notice, there is no intercept based on this equation. What that means is that it is a positive slope first off, and my line must pass through the origin. So you're going to have this a straight line graph passing through the origin. Exactly, this is exactly the graph for this equation. And the slope of this graph m is equal to f squared. The slope of this graph is f squared, and like I said, the intercept is equal to 0. Why? Because there is no intercept here. So this is exactly what we have. Okay, so that leads us to the next one. Okay, so the next one here, we have v equal to v naught exponential minus b over t. So we are given that v and t are variables, v naught and b are constants. Now, how do we deal with something like this? We are given v to be equal to v naught, then exponential minus b over t. So v and t are variables. Now already this is not looking like a straight line equation at all. The exponential here already makes it impossible to be represented as a straight line. So what do we do in a case where we have an exponential value? In the case of e, the best way to simplify this is to find the natural log of both sides. Okay, in order to transform this, we start by finding the natural log of both sides. And now that means we are going to have ln v V, okay, equal to ln, then we have V naught exponential minus B over T, okay. Now, which is also equal to, we can continue here, ln V equal to ln V naught, okay, plus ln using applying the law of logarithm. Now, ln is a logarithm. It simply means logarithm of x to base e, okay. Let me say that here. Logarithm of x to base e. That's what ln means. That's for those of us that don't know. Okay, so we continue here. So if we apply the law of logarithm, ln v naught exponential minus b over t means ln v naught plus ln, then exponential minus b over t. Okay, now we should know that ln cancels exponential the same way exponential cancels ln. So we are now going to have ln v equal to ln v naught, okay, minus b over t. Now, if you look at this, it is already looking like a straight line. The reason being that ln v here is a variable, okay? Ln v is a variable. Ln v naught is a constant, so ln v can be our y. Ln v naught is a constant, which is our c. Then b over t is constant over variable. That's constant variable. That can be our mx. So um, let me write this as I rub this off. Okay. Yeah, so this is what we have. Yes, so we can now say that ln v is our y, ln v naught is c, minus b over t means minus mx. So what does this mean? It means we have a negative slope. There's a negative slope, but we have a positive intercept. Okay, so what is our graph going to look like? Yeah, our graph is going to look like this. It's a straight line graph. The slope is negative, positive intercept. First of all, we are plotting a graph of ln v, okay, which is our y, against x. X here is 1 over t, okay, and then it's going to be a straight line graph, negative slope. That means it's going to steep downwards from left to right this way, okay, and we can now conclude that our intercept c is equal to ln v naught, and our slope m is equal to b. Okay, slope m is equal to b. That is it for that. I think this is quite interesting. This is quite straightforward. So let's proceed to the next one. The next one we have is t equal to 2 pi root g over l. T and L are variables. So T and L are variables simply means that the rest quantities there are constants. Okay, so let's see how we can transform this quickly. So we have T equal to 2 pi, then root L over G. Now the first way to transform this obviously is by squaring both sides of the equation. If we do that, we're going to have this to be T squared equal to this will be 4 pi squared, and the square cancels the square root. We have L over G. And looking at this already, it's looking like a straight line graph. Yeah, already. That's because your t squared here can be our y, that's variable. But 4 pi squared L over G can be our mx because it is constant attaching to variable. So this equation is just a simple y equal to mx equation. So in that case now, my graph is going to look like this. I'm going to plot a graph of t squared against L here. Okay, so this graph, there is no intercept, so it must pass through the origin. So, and it's a positive intercept, so it's a positive graph must go this way. The slope of this graph m would be equal to 4 pi squared all over g. That means all the constants that are attached to the variables. Let me highlight that. All the constants attached to the variables is our slope. Okay, so In this video, I'll be stopping here. If you want to get more examples, I'll be making another video to show us more examples of this. Thank you very much. Please, if you're yet to subscribe to this channel, I would um, encourage you to do so. Just click the subscribe buttons for more interesting videos. Okay, thank you, thank you, thank you.